Opposite angles are congruent. Opposite sides are congruent. Are you lost? We will go through the pink sheet in a second. Don't worry. I'm just marking it on here. Consecutive angles add to 180. So that's saying like A plus B equals 180. B plus C equals 180. C plus D equals 180. And A plus D equals 180. So consecutive angles still adds 180. And the diagonals bisect each other. So that means that, so these are all the properties of the parallelogram. So these ones are congruent and these ones are congruent. But we're going to learn something that makes this more specific. In a rectangle, all four angles are actually 90 degrees. So that means all four angles are actually congruent. And the diagonals are congruent. So that means BD is congruent to AC. So what do you know about these little pieces then here? Like BE, CE, DE, and AE. What are all of those then? They're also what? They're also congruent. So this one doesn't need that line there because all of the little pieces are also congruent. So BE is congruent to ED, which is congruent to CE, which is congruent to AE. Okay, so let's pick up that pink sheet and let's go through the rectangle column, that second column there. If it's a property of a parallelogram, it is also a property of a rectangle. So both sets of opposite sides are parallel. Is that true of a rectangle? Okay, on your pink sheet, mark that first box. On your pink sheet, mark that first box under rectangle. Again, I just keep this on my podium, not for you to steal, but for you to look at if you are missing anything, because this is all verbal. Exactly one pair of opposite sides are parallel. Is only one set of opposite sides parallel? No, that's only a trapezoid. How about the diagonals are perpendicular? Do these look perpendicular? Does that look like a 90-degree angle? No. Diagonals are congruent. Did we learn that the diagonals are congruent? Yeah, that's right here. So fill in that box for rectangles. So the fourth box down is a rectangle. Not a parallelogram, but a rectangle has congruent diagonals. Do the diagonals cut each other into two congruent pieces, bisect each other? So that is the fifth box down. You are right, that's a property of a parallelogram. So the fifth box down in rectangles also gets colored in, or checked, or X. I don't really care how you're doing it. No. Do the diagonals cut the angles, bisect the angles into two congruent pieces? No. Do we know, do these two angles look the same? No, they're not the same, so we don't know that one. But the 1, 2, 3, so seventh box down, both pairs of opposite sides are congruent. That is definitely a property of a rectangle. So the seventh box down, both pairs of opposite sides are congruent. How about only one pair of opposite sides is congruent? No, it's both pairs. That doesn't work. Are all sides congruent? No, we're not talking about a square. It's a rectangle. Okay, both pairs of opposite angles are congruent. Are opposite angles congruent? Yes, they're both 90 degrees. So, in the rectangle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th box down. Should be checked. How about exactly one pair of opposite angles are congruent? No. How about all angles are congruent? Yes, they're all 90 degrees. So that fourth box from the bottom needs to be shaded. Fourth box from the bottom needs to be shaded.
Yeah, I just did.
I'm not
I was yelling at
shading
those
it, I'm Xing it out.
Consecutive angles are supplementary, meaning they add to 180. Does 90 plus 90 180?
Yep.
Yes. So that one, the third box from the bottom, should be shaded. Each diagonal separates the shape into two congruent triangles. So if we're ignoring this diagonal here, right, this whole entire diagonal, do you see this triangle here and this triangle here? It's congruent with these triangles as well. So that is true. It cuts it into two congruent triangles, which helps us when we get to proofs that you guys love so much.
No.
And then opposite angles, yes, opposite angles are supplementary. So our A and C supplementary, our 90 and 90 supplementary. Yep, so that also gets filled in. So that very last box also gets filled in.
Right.
Any questions on your pink sheet?
Yeah, why didn't you do
Because you guys love them so much. I cannot hear enough how much you love them every single time you teach them.
We're having our proofs quiz.
You won't have a proofs quiz, but you'll have a quiz over this stuff probably Thursday or Friday. I gotta look into that.
And will there be proofs on that?
I don't know. I'll look at it. I don't think so yet. Like, on the test, the proofs are only like the fill in the blank or correction proofs, like your homework work. You know what I'm saying? So like how one of them was like a correction, another one. So it's similar to those ones. All right, so let's use our properties. Given that quadrilateral ABCD is a rectangle, find the following. Find x if AC is 2x plus 13 and DB is 4x minus 1. What do you guys know about AC and DB?
They're congruent.
These pieces are congruent. So what can you do when two things are congruent? So we can set them equal. Diagonals of a rectangle are congruent. Do you guys see how this is going to get really confusing really quickly when we mix all the shapes together?
Yeah. We have to mix them.
Oh, yes. So you're going to have to separate all of the properties and know which things go with which, because the diagonals are not congruent in a parallelogram, and you need to know that. Apparently Greg's already done. So yes, x does equal 7, as Greg has already told the whole entire class. Boom. Says find AC if AE is 3x plus 3 and EC is 5x minus 15, 5x minus 15. So what do you guys know about AC in AE? Or EC and AE? I can't speak. AE and EC. What are they? I'm glad that Abby knew what I was talking about, even though I cannot speak. They are congruent. The diagonals bisect each other, so they are congruent. And then it tells us to find AC. So we need to make sure we're finding what we're supposed to find. So the first thing we need to do is find x.
9.
Nope.
Yes.
Somebody's music is on. Turn it off. All the way off. I can hear it. All the way off.
Can I just see if they said that they'll give me food?
Told you.
No, I'm just go right. 9.
Oh, x is 9, but that's not what we're finding. What are we finding?
AC.
AC is adding up AE and EC. Do you guys see that? So I'm going to do 3 times 9
No, wait.
plus 3 plus 5 times 9 minus 15. So we're plugging in 9.
Crap.
How is it? What did you say you got?
31.
I'm thinking that's not right. I'm thinking that I'm not even that
You were finding ACs. Wouldn't you just
AC is the whole entire length.
Yeah, Greg. Yeah, but
So
it's just AC on number 1, 2x plus 13. So
These are two separate problems. They're giving you different pieces. Just because you didn't get it right this time, Greg, doesn't make it stupid. It's okay. Find x if DAC DAC is 2x plus 4, and BAC is 3x plus 1. What do you know about those two angles? What do they make? A right angle, which means they add to 90. So 2x plus 4. Come on, Greg. Get to work.
I'm trying.
Plus 3x. You're just angry at yourself. It's okay. Mistakes happen. Did you hear how I said rectangle earlier? It was terrible.
I mean, but you.
It's good. All right. So, do we have questions? Guys, do we have questions on those first examples there? I forgot to make this AC equals.
Yeah.
What questions do we have so far? Guys, it will be beneficial. Please listen to me. It would be beneficial to go back and look at your trapezoid property notes and your parallelogram property notes and these property notes at the same time so you can start separating which properties go with which. You guys need to spend some time looking at that stuff on your own. That's a study habit right there that some of you guys will do. I assume some of you will not, but I'm telling you now that it will be helpful.
I know you were talking about.
In general. Given that quadrilateral ABCD is a rectangle, find the following. If BC is 24 and AD is 5y minus 1, find y. What do you guys know about opposite sides, Olivia, of a rectangle? Yes, they are. So we set them equal.
I like you ask everybody and then you're just like one person. You're like, everybody, what is...
I know. It's because you guys are then aware that you could be called on at any moment. Although Greg is answering every question today, so.
I'm so glad it's not like algebra 1.
What'd you say?
Nothing, because then you're going to do.
All right, so it says if the measure of
I need a calculator.
ABD is 7x minus 31, and CDB is 4x plus 5, find ABD. What do you guys know about those two angles?
7 times 12.
What kind of angles are those two? They're alternate interior angles. Look at this. If lines are parallel, which these two are, cut by a transversal, which that's the transversal. I don't know what's happening. Stop. Then alternate interior angles are congruent. So these two angles are alternate interior, so they are congruent. So I'm going to do 7x minus 31 equals, boy, stop, 4x plus 5.
Whenever I suck at it.
What was it? Maybe it was 54.
But it doesn't ask for x, it asks for the measure of ABD. So what do we do to find ABD? Substitute it in.
Now you know it.
So 7 times 12 minus 31. So the measure of angle ABD is 53 degrees. Good job. You're okay. It's okay.
I'm hungry.
Says if the measure of angle BEA is 62, BEA find the measure of angle BAC. This one. What do you know about these two angles here? What do you know about these two angles here?
Congruent?
They're congruent. This is an isosceles triangle because we know this piece is congruent to this piece, right? So if sides, then angles. So we can call those both the same variable. I'm going to call them both x. How many degrees are in a triangle? Try that again.
180.
So we can do x plus 62 equals 180, because those angles, I just called them x because they're the same measure. So you could have called them y, you could have called them z. I'm just saying those two have to be the same. What'd you just ask? He said if one is already 62, why can't it just be 62? So it's not like that. This is not the base angles. This is the vertex angle. Okay. Is it 59? So that means the measure of angle BAC is 59. That one's confusing, so please ask questions if you're lost. That one may not make as much sense as some of the other ones we've done. So please make sure you're asking questions. Or maybe none of it's making sense and you have a question. Either way, please ask a question. Keep going until I'm done. So do we have any questions? Again, the hardest part is like when we put them all together. When you have separate, it's pretty easy because you can just focus on those properties. And not that it's pretty easy, I shouldn't say that. It's just easier than when we put them all together. So quadrilateral MNOP is a rectangle. Given that the measure of angle 1 is 40, find the measure of each numbered angle. So if this is 40, what other angle is 40? Measure of angle 2 is also 40. Devin, what angle do you want to help me find?
Measure of angle 6.
Okay, how would you find the measure of angle 6?
You would add 40 plus 40 to 80, minus that with 180 would be 100. And the vertical angle.
So you know that these two angles are vertical, so that is also 100. You are right. Okay, Kylie, give me another angle that you want to find.
Can't you do 5?
Yeah, how would you find the angle 5?
Well, they equal to 180, so 5 would be
5 would be what?
80.
Yep. 100 plus 80 is 180. Because you're trying to get those to be a linear pair. Gabe, find another angle. Angle 3 is what? How did you get that? So 40 plus 50 is 90. So what do you know then, Gabe, about angle 4? Angle 4 is congruent to angle 3, so it's also 50 degrees. So questions on finding the angles if you're given one. Are we doing okay there? Please ask questions. What? What doesn't make sense? Math does make logical sense. It is logical.
Usually the proofs don't make sense at all.
Yes, they do. Determine if the following statements are true or false. If false, provide a counterexample in form of words, definitions, or correctly drawn and labeled with marking diagrams. It needs to be very descriptive. So the diagonals of a rectangle are congruent. Is that true or false? Is that true or false?
True.
True. The opposite angles of a rectangle are complementary. Is that true or false?
False.
That is false. So I'm going to use words here because opposite angles are what? Supplementary because both of them are 90 degrees. Okay, 90 plus 90 is 180. So 90 plus 90 is 180, not 90, which is what complementary would be. Determine if the following statements are true or false. If it is a counterexample and you're using a picture, you must label it correctly. Every parallelogram is a rectangle. Is that true or false? What? False. If I draw this as a counterexample, and I label it, I'm just going to give it certain degrees. It doesn't really matter. If I label this, this is not a rectangle because all of the angles are not, all angles are not 90 degrees. Also, if you look at it, it doesn't look like a rectangle. So, all angles are not 90 degrees, but they're still consecutive angles. They're still supplementary there. Every rectangle is a parallelogram.
True.
That is true. It holds all the properties of a parallelogram. All right.